When you learned how to factor quadratic expressions, you may not have been entirely sure why you needed to know how to do that. In this video, we learned that factoring helps us solve quadratic equations. We'll learn other methods to solve quadratic equations, but factoring is often the easiest way to do it. Let's dive in and take a look. Before we learn how to solve quadratic equations by factoring, let's review factoring. So here we're trying to factor n squared plus 2n minus 35. So we are going to break it down, or try to break it down, into two binomials that when we multiply those binomials, we end up getting this expression. So because of how the multiplication works out when we multiply two binomials, we need to find two numbers that multiply to make negative 35 that add up to positive 2. Well, we know that 7 times 5 is 35, and they have a difference of 2. We're going to make the 5 negative so that when we add 7 plus negative 5, we get a positive 2. So our factors here must be n plus 7 and n minus 5. Always keep in mind that if we were to multiply these two binomials, we would have 4 little multiplication problems, and we'd end up with this expression here. Now this expression is a little bit different because there's a coefficient in front of the squared term. In that situation, the first thing we should look for is a common factor that we can factor out. In this case, there is one. We can divide each of these numbers by 5. So let's factor out that 5. So I'm going to divide out a 5 from each of the three terms. 35 divided by 5 is 7. 150 divided by 5 equals 30. And 40 divided by 5 equals 8. When we factor out the 5, we still have a coefficient in front of the squared term. Now, when you have a coefficient like that, the diamond, or the x, works a little bit differently. Instead of putting the 8 up here, we have to multiply 7 times 8. And so we'll put 56. But the 30 still goes on the bottom. So now we're trying to think of two numbers that multiply to make 56 that add up to 30. Well, when we see 56, the first two numbers that probably come to mind are 7 times 8. But those don't have a sum of 30. The only other pair that is obvious is 1 times 56, but those don't have a sum of 30 either. But then we notice 56 is an even number. So 2 times 28 equals 56, and notice that 2 plus 28 does equal 30. So we completed our puzzle here. Now we don't go directly to the factors yet. We're going to use these to help us fill in the rectangle. So I go back to the original expression of 35n squared So now we're not going to go all the way back to the original expression because we already factored out the 5. So we'll be using this expression here. So I have 7n squared in the top left, and 8 in the bottom right. And then these two wing numbers here tell us what go in these two wing numbers tell us what goes in the two empty boxes. So I have 2n and 28n. Right, to make 7n squared, it's going to be 7n times n. So we're going to line up the 7n with the 28n. Then n times 2 equals 2n. And 7n times 4 equals 28n. And notice that 2 times 4 does equal 8. So now these expressions on the borders are the factors. So we still have that 5. And we have 7n plus 2 and n plus 4. Now, to use factoring to help us solve a quadratic equation, we're going to be using something called the zero product property. Now the idea here is if we have some mystery number multiplied by, let's just say like 8, and that product equals 0, well, we know that one of these two numbers must be 0. So this mystery number here has to be 0. That's the basic idea of the zero product property. So if we multiply two numbers and get 0, so let's just say A times B equals 0, then we know that one of those two numbers must be 0. So we could say if A times B equals 0, then either A or B must equal 0. Now we won't go through these steps for solving quadratic equations by factoring right now, but they're here for you to refer back to. So here we have a quadratic equation. We know it's an equation because it has an equal sign. And we know it's quadratic because if we were to multiply these two binomials, well, n times n is n squared. So this is a quadratic equation. Now, we notice here that we have one binomial multiplied by another. So in other words, we have two things being multiplied, and that product equals 0. That means that one of these two binomials must equal 0. Well, if the first binomial equals 0, then we could just say that n minus 2 equals 0. And we'll solve that for n. And we get n equals 2. That's actually one of the solutions to this equation. If we substitute 2 for n, we get 2 minus 2 times 2 plus 5. And we're wondering if that equals 0. Well, 2 minus 2 equals 0. And 2 plus 5 equals 7, and 0 times 7 does equal 0. So that's using the zero product property to solve a quadratic equation. But we have one more binomial here. And if this binomial equals 0, that would also solve the equation. So we'll solve for n when n plus 5 equals 0. So here we have two solutions for n. N equals 2, and n equals negative 5. Notice we could substitute negative 5 for the n's, and we would have negative 7 times 0 does equal 0. This one looks a little bit different. We have 2k times 3k plus 1 equals 0. Well, let's see, this 2k here, if that equals 0, well, we could divide both sides by 2 and get k equals 0. So there's one of our solutions. If we replace both k's with 0, we'd have 0 times 1, and that does equal 0. All right, let's figure out what k makes this expression equal to 0. So we'll just write a little equation here, 3k plus 1 equals 0. Because remember, we're just wondering what value of k makes this expression 0, so that the zero product property works. Let's go ahead and do our algebra. We'll divide both sides by 3 here. We get k equals negative 1/3. I'm just going to move this down here. So we have k equals 0 and k equals negative 1/3. Now, these last two examples, the quadratic equation was already factored. Let's take a look at some examples when we need to do the factoring ourselves. So here we have a quadratic equation that we need to solve. And let's check to see if this quadratic expression here is factorable. If it is, then we can solve it by factoring. So we're looking for two numbers that multiply to make 18 that have a sum of negative 9. Well, we know 6 times 3 is 18, and negative 6 times negative 3 equals positive 18, and these have a sum of negative 9. So we found our two wing numbers. So let's use those to help us write our factors. We have m minus 6 times m minus 3. And that equals 0. So here we factored our quadratic expression. And now we can use the zero product property to solve for m, because we have something times something equals 0. So one of these two binomials must equal 0. If it's the first one, then m must equal positive 6. And if it's the second one, well then m must equal positive 3. And either one of these answers would work if we plugged it into our equation. If we substitute 3, we'd have 3 squared, which is 9, minus 27, which is negative 18, plus 18 equals 0. Here we have another quadratic equation. Let's see if we can factor this quadratic expression. We're trying to think of two numbers that multiply to make negative 8 that have a sum of negative 2. Looks like negative 4 times positive 2 will work because these have a product of negative 8 and a sum of negative 2. So our factors are x minus 4 times x plus 2. So we have something times something equals 0. One of these two binomials must be equal to 0. So if it's the first one equal to 0, then x must equal 4. And if it's the second one that's 0, well then x must equal negative 2. So we started with a quadratic equation equal to 0. We factored the quadratic expression and used the zero product property to solve for x. Taking a close look at this quadratic equation, there's something different about it. In this equation, it doesn't equal 0. It equals negative 6. Now, the zero product property only works when the equation equals 0. So we need to be careful about that. So before we use this method, the first thing we should look for is to make sure that the equation equals 0. Well, since this one doesn't, let's go ahead and use our algebra to make sure it does equal 0. So we'll add 6 to both sides. So we rewrote the equation so that it equals 0. Let's try to factor this quadratic expression. If it's factorable, then we can solve the equation by factoring. Trying to think of two numbers that multiply to make 3 and have a sum of negative 4. Well, that would be negative 3 times negative 1. So they have a product of positive 3 and a sum of negative 4. These wing numbers will help us get our factors. So we have m minus 3 times m minus 1. And that equals 0. We have something times something equals 0. One of these two binomials must equal 0 in order for this to be true. If it's the first one, m is going to equal 3. If it's the second one, m is going to equal 1. And we can always show why that's the case by working out our little equations here. And notice if we substitute 3 for m, we would get 3 minus 3 equals 0, which would help make the zero product property work. In this last example, we have a quadratic equation. There is a coefficient in front of the squared term, and the equation does not equal 0 yet. So let's go ahead and move everything on the right over to the left so that we can get this equation equal to 0. I think I'll add 3p to both sides first. These are not like terms because one of the terms is p squared and the other is just p, so we'll keep those separate. The minus 3 tags along for now. These cancel, that's why we added 3p to both sides. We still don't have the equation equal to 0, so let's add 4 to both sides. So now we have a quadratic equation equal to 0. Let's see if we can factor this quadratic expression here on the left so that we can solve this quadratic equation by factoring. All right, remember when there's a coefficient in front of the squared term, you have to multiply that coefficient by the constant term. So 2 times 1 is 2. So we're wondering if there are any numbers that multiply to make 2 that have a sum of 3. Well, there sure are, aren't there? 2 times 1 equals 2, and 2 plus 1 equals 3. Let's use that 2 and the 1 to help us fill in our rectangle. First, the top left corner will be 2p squared. And the bottom right will be 1. And then the left wing number, we can put that here as 2p. And the right wing number, if we can put that here, as 1p. And let's fill in the border here. To get 2p squared, that would be 2p times p. Well, I'm going to line up the 2p above these 2p's here, so I don't end up with a fraction. So I have p times 2p equals 2p squared. P times 1 is 1p. And 2p times 1 equals 2p. And 1 times 1 equals 1. So we have our factors. So we have something times something equals 0. One of these two expressions must equal 0. If it's the first one, then 2p plus 1 must equal 0. So I solved that equation for p and got negative 1/2. Or on the other one, we have p plus 1 equals 0. So both negative 1/2 and negative 1 should work in this equation. If we try that with negative 1, well, negative 1 squared is positive 1, times 2 is 2, and 2 minus 3 is negative 1. Negative 3 times negative 1 is positive 3 minus 4 equals negative 1. So that did work. In this video, we solved quadratic equations by factoring. Hopefully this video has been helpful. This is Mr. Ela, signing off.